Lesson 21, Acceleration Due to Gravity. This is going to be one of those lessons where we're going to build on information that you already know. So you're not really going to learn anything new mathematically, but we are going to be taking a look at some things that you already know and applying them to a very specific situation. Objectives are first to define what we call free fall. The second is to evaluate objects that are in free fall. And lastly, to be able to perform mathematical analysis of objects undergoing free fall. So let's start with our definition of free fall. Free fall is essentially when the only force acting on an object is gravity. On the Earth, we would say that when an object is in the air, if we ignore air resistance, so the air resistance has to be so small that we don't worry about it, then the only force acting on the object is gravity. If we're talking about an object, say, in space, or say on the moon where there is no air, then we don't have to worry about air resistance in the first place. So if we were to drop an object, and the object is heavy enough, we don't need to worry about air resistance. But in the case of dropping something like, say, an open piece of paper or a leaf, the air resistance is really important, and it is going to act on the object and slow it down. So it's important that only gravity is the force that we are concerned about. There are no other forces acting on the object. When this is the case, we say the object is in free fall. Now, free fall can also be a bit deceiving. If we were to throw an object up into the air, a heavy object like, say, a baseball, then as soon as it leaves your hand, the only force acting on the object is gravity. So as soon as the ball leaves your hand, the object is considered to be falling. This is because the only force acting on it is gravity. If it weren't falling and we threw it upwards, it would continue moving upwards. But because gravity is acting on it, it slows down, stops, reverses its direction, and then comes back down. So really, it is falling. So it's a little bit more complicated than we first thought. Now, any object that is undergoing free fall experiences an acceleration towards the Earth. So in other words, it's speeding up. There's an acceleration towards the Earth. And that acceleration is at a number that you're already familiar with, 9.8. In this case, since it's an acceleration, it's 9.8 meters per second per second. So when you're doing some problems, you're going to encounter words. So this is another situation where words are going to be really important because they're going to tell you things. One of the things is if the object is dropped. If the object is dropped, it's telling you two things. It's telling you that the initial speed is 0, because if it's dropped, it's initially not moving. It's also telling you that its acceleration is 9.8 meters per second per second. So it's important when you're looking at a problem to see if an object is falling or dropped. It's not going to come right out and tell you that the acceleration is 9.8. You're going to have to determine that from reading the problem. Now, you can put on your formula card next to your acceleration equations that for free fall, A is equal to 9.8 meters per second, because this will always be the case for free fall. Let's take a look at an example. It says, a ball is dropped from a window. What is the speed of the ball after 5 seconds? Now, this problem can be a little confusing for some people, because if they're just looking for numbers, the only thing that's given in the problem is a time of 5 seconds. So if we go through and gather information from carefully reading the problem, let's see what we end up with. Remember, we first start by looking at what we're trying to find. In this case, the speed of the ball after, which is going to be a final speed. We have a time, 5 seconds. Now we have the word dropped. Remember, dropped is telling us two things. It's telling us that the initial speed is 0 and that the acceleration is 9.8 meters per second per second. So notice that we're using the formula for a final velocity from our acceleration formulas. This is always going to be the problem or the equation that you're going to use for this course to solve a free fall problem. So now we can just substitute our values in. I did put the units in so that you could see what's going to happen. Notice that when the seconds with the 5 is multiplied by the meters per second squared with the 9.8, that one of the seconds cancels. So we will end up with meters per second, which is a speed, which is what we'll expect. When we determine this, we get 49 meters per second. So that's our final answer. But the idea is that whenever an object is dropped, falling, or thrown, its acceleration is going to be 9.8 meters per second squared. And you will use this equation, the final velocity equation, not the average speed formula. You can't use average speed in this case because the object is accelerating.